Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. What is the major product of this reaction? Now if you look at this molecule, it's a very interesting molecule. I request everyone please pause the video, try by yourself, whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now the question, what is the major product of these reaction? If you look at closely, this is the aromatic hydrocarbon with some substitution and it's treated with acetyl chloride AlCl3, second step water. So first step is actually aromatic electrophilic substitution, or more specifically if I say Friedel Craft acylation. Why? Because acetyl chloride is used, and second step is actually workup. And if you look at here from all the products, you can also understand actually it's a substitution. See, these protons are substituted by acetyl group. So actually if I say this question is about the regioselectivity for substitution reaction, for that purpose let's go to the mechanism first. I mean about the electrophile generation. Since I told it's an aromatic electrophilic substitution, so how the electrophile is generated from this combination. Now if you look at this aluminum chloride, by the way student, AlCl3, people consider it's a ionic compound, aluminium electropositive element chlorine, but actually it is not. This AlCl3 is actually a covalent compound. AlCl3, AlBr3, Ali3, they are covalent. Only aluminium trifluoride is ionic. Okay, so here you can see this aluminium has 3 bonds with 3 chlorine. Each bond contributes 2 electrons, so total 6 electrons surrounding this aluminium center. So this aluminium is having 6 electrons in its outermost shell or valence shell. But recall the octet rule. Every element prefers to keep 8 electrons in its outermost shell in order to have nearest noble gas electronic configuration. So in this case, aluminium, if I say, it wants to have argon's electronic configuration. But right now it is not possible in this AlCl3 compound. Why? Because it has 6 electrons. So it needs 2 more electrons such that it can attain nearest noble gas argon's electronic configuration. But there are 3 chlorine attached, and by the way, it has a vacant p orbital also. Because of this p orbital, it acts as Lewis acid. By definition, Lewis acids are electron deficient molecule which can accept a pair of electrons. Now here who can act as Lewis base? So if you look at, there are 2 options possible. What do I mean? So this oxygen has 2 lone pairs, and by the way this chlorine has 3 lone pairs of electron. If you want to think from octet count point of view, both are oxygen and chlorine octet filled. Now first you can say, sir, aluminium oxygen bond is very stronger, second row, third row. Okay sir, so this donation will be dominant. I agree student. It is actually, if I say, it's a reversible reaction. This donation possible, but this doesn't have any fate. And as I told, it's a reversible, so it can break. Again, this chlorine can also coordinate to the aluminium. Means then this coordination will be broken. So what will be the thing? This chlorine is donating. Now you may think, sir, aluminium chloride, in this case chlorine is very electronegative atom. Why it donate? If you look at the electronegativity value, oxygen's value nearly 3.5, chlorine's value nearly 3. So by definition, chlorine is relatively lesser electronegative atom, so it can donate more efficiently. That's the reason. Now this carbon chlorine bond is not that much stronger like carbon oxygen, and not only that, this chlorine has donated a pair of electron to this aluminium's vacant p orbital. Okay, now since chlorine has donated electron density, so chlorine will have a deficiency of electron that is designated by this positive charge. Aluminium has gained some amount of electron that is designated by this negative charge. By the way, previously there were 6 electrons because of 3 bonds with this aluminium, so 6 electrons there. Right now, because of this bond, this is actually coordinate covalent bond, this aluminium center is 8 electron filled, or you can say it has octet filled structure. So it is relatively stable. So that is the reason it acts as Lewis acid, and because of this it result Lewis acid base adduct. So this is Lewis acid base adduct. Now next phase, what happened? See, chlorine by nature is actually a very electronegative atom. So it's carrying positive charge, it's not that much stable. So this bond breaks and it produces this AlCl4 minus this plus charge. By the way, do not think they are very stable. No. They are moderately stable. They are produced as intermediate, and when they produce, they will participate in the reaction further. But one information I want to mention. Student, you may think, sir, sp2 carbon. This is sp2 carbon. Previously, from there you can see this is the sp2 hybridization. So why this sp2 carbon is stable? Is there any specific reason? Yes, student. These acylium cation can undergo a resonance. Actually, if you look at this carbon, after this plus charge, having this plus charge right now, it is also 6 electron. When you look at here, this is a double bond, 4 electron, 2 electron, 6 electron, 2 electron, 8 electron. Right now this bond pair is gone with the chlorine. So right now this is a 6 electron. So it can have a resonance. Resonance means one pair could be donated and it can have a planar structure. Okay, still one electron pair remaining, positive charge. Now you may ask one question, that sir, why this canonical form is stable? Because electronegative atom oxygen is carrying positive charge. Is it really stable? Actually, there is some logic. Logic is that in this canonical form, if you look at this carbon is octet filled, because one bond 2 electron, triple bond 6 electron, so carbon is 8 electron. Not only that, this oxygen also has 8 electron. So in this case, both of the atoms have octet filled structure, whereas in this case this carbon atom is incomplete octet or sextet. So that is the reason this canonical form will have a significant contribution. Now AlCl3 is a covalent compound, and how acylium cation is resonance stabilized I have explained. Next. So the next part, electrophile is generated. Remember, electrophile means they are electron deficient. Positive charge is the indication of electron deficiency. Now if you look at benzene rings are, by the way student, they are electron rich because 6 pi electron are in resonance. So okay, it will react with this electrophile. But the question, if you look at this molecule, there is one proton here, one proton here, one proton here. Let's name them H1, H2, H3. So where the substitution will take place. And by the way, if you look at other position, I'm talking here, here and here, they are blocked by this carbon atom. So reaction, aromatic electrophilic substitution will not take place at that position. Now if you look at here, this electrophile, just imagine if it goes there. By the way, structure you can see option A, electrophile goes there. So if it goes there, so there will have a significant amount of repulsion, steric repulsion, because this side CH3 and this is the tertiary butyl group, very big. So electrophile cannot access this position. So aromatic electrophilic substitution means electrophile attack on this carbon is not possible. So HA is gone. Next option, if you say H2 versus H3, it has a real tough competition, I would say. Now if you look at the ring properly, so here this dimethyl and here this tertiary butyl group. Now these two proton number H2 or H3. If you replace H2, if you want to say, then this acylium cation need to go closer to this tertiary butyl group. Remember student, tertiary butyl group is very bulky. So that has a negative point. By the way, you can say that other side is H3. Okay, fine, accept. Next, if you say, let's check the AES at this side, what could be the advantage as well as disadvantage? Now, if it attaches, one side is hydrogen, that is the same like the previous one. Now, but here, if you say this is actually CH2, previously it was tertiary butyl group. So this side is student lesser bulky. 1 point. So approach at this position is preferred. Point number 1. So it is steric reason. Second part is actually the electronic reason. Means here if you say all are methyl group, carbon bond, But if you look at, there is actually one carbon-carbon bond and two hydrogen. So these two hydrogen can participate in hyperconjugation, and that is an additional stability, because we have studied previously that hyperconjugation is more effective stabilizing carbocation compared to plus I effect only, because plus I effects operates through the sigma bond, but hyperconjugation operates through a pi type interaction, means CH sigma participates in delocalizing the electron density of the sigma bond to the carbocation. Now let me show. So this position is actually more preferred, H3. So H3 position, if the electrophile get attached, then the positive charge will go to here, by the way, hydrogen, and here this group, I mean CH3CO acyl group. Okay, so rest of the thing I'm drawing as it is. Now if you look at, there are two hydrogens, so they can result in hyperconjugation. That is actually a significantly extra stability. With respect to positive charge, this carbon should be called as alpha. Not only that, if you say this carbon's position is benzylic, even it is also benzylic, if I say logically, but they do not have hydrogen. Here 3 methyl group, here 2 methyl group, all are, if you look at these carbons, are quaternary in nature. But if you look at this carbon is secondary. So secondary means it is attached to two hydrogen, so two extra stability hyperconjugation possible. So that's why it will be produced. Now if you look at this complex is called as sigma complex, but in this sigma complex the special stabilization, I would say aromaticity is gone, because there is positive charge and here is, this is sp3 hybridized carbon. Remember student, aromaticity, it's a very high stability. Molecule tries to have it, try to gain it. So what it will do, this will release this proton and this bond pair will go there. And what will be the product? So here the acetyl group will be attached there. This is, so what is the main controlling factor? Main controlling factor is the second point, that is hyperconjugation. And obviously the first one is a steric point of view, so these will be the product. Now, so why the second step water is given? Remember student, these water presence, because in order to do the workup, because in reaction medium LCl3 there. But what is the overall reaction if I say? Then whatever product I have written plus along with that one molecule HCl is produced. From where this Cl comes? Cl comes from here and hydrogen comes from this position. So in order to quench, neutralize or remove this organic compound, this HCl, this workup is done. Actually workup is a purification strategy such that we can get our desired target organic compound properly. So this is the answer. So here I guess you have understood this option C is the right answer. Two reasons. One is less bulky, steric factor, as well as hyperconjugation, electronic factor is the reason. Now if you get this question in your exam hall, how can you solve it less than 30 seconds? So if you look at the options very carefully, actually three position remaining as I told. What is about the fourth? It's a benzylic substitution. Isn't it logical under Friedel Craft reaction condition or Friedel Craft acylation reaction condition? So it will go. Remaining three. Now if you look at very carefully, this position is actually in between the two sides. So here one substitution, here one substitution. So I guess you can remember ortho effect or ortho dialkyl effect or steric inhibition of resonance. By the way, I've already discussed a dedicated lecture on it, you may learn. Because of these two ortho group property changes, so approach of electrophile at this position is prohibited. Common sense says. So option A also gone. Now the tough competition is between option B and option. How can you decide whether it will go? So in this case student, you need to think closer to tertiary butyl group, bigger group compared to here. Okay, this side is less bigger, so possible. Second thing, if you compare, all are actually alkyl group. So this is alkyl group, this is alkyl group, and this is alkyl group. So which one will contribute more? So with respect to this alkyl group, this ortho is vacant, para is blocked, this ortho blocked. Now with respect to this is ortho, this is para. And if you look at with respect to this is ortho, this is para. So from there we know, actually remember one thing, when tertiary butyl group there, means electrophile prefer not to go to the ortho position because of the bulkiness exerted by this tertiary butyl group. Okay, so in this way you need to come quickly that okay, option C will be the answer. I know it is little confusing, but you have to study such that you know the answer. But by the way, one thing I told here in from this sigma complex to this, aromaticity gaining is the driving force. Now if I say aromaticity gaining is it's so much important, then why this reaction takes place? Because in the first step, if you look at, the aromaticity is destroyed. Why the reaction afford to aromaticity destruction? Means why the first step happened where aromaticity is destroyed? Because I told it's a very high stability. So why molecules are ready to sacrifice this stability? Remember one thing, if you look at this ring, electron rich because of the substituents. Not only that, benzene ring has 6 pi electron, so significant electron density it has. When this group get attached, the electron density is also to some extent delocalized because this group is electron withdrawing in nature. So the higher delocalization of electron take place, stabilization. Generally we say if you introduce an electron withdrawing group, the ring get deactivated, means not interested to do chemical reaction. Why? Because it itself very stable, that's why it doesn't want to react with other. So try to understand the basic concept, do not memorize blindly. So this is the overall discussion and the tricks. As I told, you need to understand the position and the nature of the group, and based on that you need to decide. You have to check where the nucleic attack. Remember, any chemical reaction is guided by two principles. One is by collision theory, another is transition state theory. So what collision theory says? Collision theory, where the effective collision is more probable. Here more probable because bulkness is least. Okay, and the stabilization point of transition state intermediate I have told because of hyperconjugation. So if you understand this thing, if you can think it very quickly, it could be done very fast. So this is the overall discussion. I believe you have learned a lot, and if you really consider the content of my channel worthy, please help this channel to grow. And regarding any doubt about the logo of my channel, I request please read this part, your doubt will be clear. So thank you, see you in my next video. Bye bye.